Hi, good evening, children. Today, in our class 6, we shall start in physics. We shall start second chapter in our IIT Foundation course. Get ready, children. This class will be very beautiful, and you will definitely say it will be more attractive, right? See now. Let us discuss. So, the second chapter is fundamental measurements and motion. So, the first topic is measurement and the second topic is motion. Measurement of length, mass, time, temperature, so on, etc. we are going to discuss here. And in case of motion, we are going to discuss those topics: rest, motion, distance, displacement, speed, velocity, so on. Right? Alright, see now, we shall start our class. See, the first thing is in period 1, in this period what we are going to discuss is importance of measurement in everyday life, physical quantity and its types, units and its types, system of measurements, fundamental units of SI system, the measurement of length, need for standard length, standard unit of length, how to measure the length accurately with meter scale, error while measuring the length, and so on. We are going to discuss this kind of topics. We shall discuss one by one. Okay, children, importance of measurement means why we should measure the thing. What is the necessity of measurement? So, why do we need a measurement? See, children, you are going to shop and you are going to buy some rice, and even we have to buy daily, we have to buy milk, we have to stitch cloth. For us, we have to take shirt or pant, we have to take some cloth and go to the tailor in order to stitch. To know the time, what is the time now? To check the fever, you will go with the doctor and he will say you will have that much of fever. And to buy vegetables. For all these things, you need some instrument, you need some measurement, you need some quantity. In order to measure fever, we need something. In order to measure vegetables, in order to weigh the vegetables, we need some other instrument. In order to watch the clock, or in order to see the time, we need some device. Okay, likewise, for all the things we need different kinds of devices in our daily life. Right? What is measurement? What is measurement? The only physical quantities can be measured, but not feelings. Okay, we cannot measure feelings with these quantities. We have feelings: happiness, sorrow, okay, jealousy. These are all feelings. Okay, that is innated within the person. We cannot measure with these physical devices, but we can measure what? These kind of things. Milk in different units or different quantities. We are going to measure this. Right. Basic measurements. Length. For example, in order to measure length, we need ruler. What is ruler? In the sense scale. Next, the unit of measurement is measuring the length is meter. Okay, and the unit of time is second, minute and hour. Okay, next, mass. In order to measure the mass, we need some balance, weight or mass in generally measured in kilograms. Okay, what is measurement? Now we go for the definition of measurement. Measurement is comparing an unknown quantity with standard unit. Comparing the unknown quantity with standard unit is called measurement. So, what is measurement? Comparing the unknown quantity with standard unit is called measurement. So, unknown quantity. I have taken some vegetables in my hand. I don't know what is the weight of that vegetables. Okay, I have few vegetables in a cover. I don't know what is the weight of those. So for that what I have to do? I have to weigh. In order to weigh, we need a standard unit. What is the standard unit there? 1 kg is the standard unit. How many times this 1 kg, this cover is? Whether it is 2 times. If it is 2 times, the cover full of vegetables are 2 kgs. If it is 3 times, the cover full of vegetables are 3 kgs. A person will stand on the weighing machine. How many times he is having the weight of 1 kg? The 1 kg is called standard unit. So what is measurement? It is comparison of unknown quantity with the standard unit. So what is the standard unit here? 1 kg is the standard unit. How many times 1 kg? A person may be 50 kgs. Okay, he is 50 times the mass of that is standard unit, that is 1 kg. Alright, there are special measurement tools. One is vernier calipers. Okay, so likewise screw gauge. We are going to have different physical balance. Those are measuring tools in order to measure different things. Next, we go for physical quantity and its types. The quantities which can be measured physically with our hands. Directly we are going to see and we are going to measure with our hands. We are going to do the work with our hands physically. Those quantities we call it as physical quantities. So for example, like length, mass, time, which are not based on other physical quantities are called fundamental physical quantities. So what are fundamental physical quantities? Fundamental physical quantities are nothing but basic physical quantities. They do not depend upon any other physical quantities. Any other quantities. We are called fundamental physical quantities. The best examples are length, mass and time. Okay, they are independent of other physical quantities. So those quantities we call it as fundamental physical quantities. What are derived quantities? Derived quantities are depend quantities, depend on fundamental quantities. The quantities which depend on fundamental quantities are called derived quantities. Example for fundamental quantities: length, mass and time. Length, the quantity length is the basic unit, fundamental unit. Fundamental means least, basic unit. So length is basic quantity, length. So we don't have much smaller than that. So it is the smallest one and it is the basic one. So it is not depending on any other thing. So that is why it is considered as fundamental quantity, even as that of mass and time. See derived quantities here, for example area. In order to find the area, so generally if you take a rectangle, what is the area of rectangle? Length into breadth. Breadth is also one of the length. So area is depending on two lengths, length into length. So length is fundamental quantity. So area is derived quantities because area is depending on two lengths, two fundamental quantities there. There may be same or different. Even volume. What is the formula for volume? Length cube, length into breadth into height. 3 are lengths. So volume is depending on those fundamental quantities. So the quantity which is depending on the fundamental quantity is called derived quantity. Okay, to measure the area of the rectangle, we need to multiply length into breadth. Therefore, area is derived quantities. Likewise, we are going to get much things in few, right? We will discuss. See now, fundamental or derived quantities. We are having few quantities here. We have to differentiate which one is fundamental. See here, weight, mass, density, volume and speed. Here the fundamental quantity is mass. Mass is the fundamental quantity and all other are derived quantities because length, mass, time are fundamental quantities already we have discussed. So in these we are having only mass. Weight is not a fundamental quantity. Weight depends on force. How it will depend we will discuss in forthcoming classes, right? Weight, density and volume and speed all are derived quantities and here mass is fundamental quantity. Right. Types of units. Till now we have discussed fundamental quantities, types of units. Those are fundamental units and derived units. That is with quantity we are having unit. Used to measure the basic physical quantities. I mean the units which measure the basic physical quantities, that is fundamental quantities, are called fundamental units. They do not depend on other units. Example are, in order to measure length, the unit is meter. In order to measure mass, kilogram. Time, second. Temperature, Kelvin. These are fundamental units. Derived units are, these are the combination of fundamental units. The combination of fundamental units will give you the derived units. Okay, they are very different. So density, kilogram per cubic meter. Here kilogram, kg is the unit of mass and meter is the unit of length. So density depends on both kg and meter. So density, here it is derived quantity. Speed is also derived quantity. Right. Next one, system of measurements. So in order to measure, we are having different kinds of system. One is CGS system, FPS system, MKS system and SI system. What is CGS system? Centimeter, gram and second. C means centimeter, G means gram, S means second. So length is going to be measured in centimeters, mass is going to be measured in gram and time is going to be measured in seconds. FPS system, foot, pound and second system. Length, there we are going to measure in terms of feet, mass we are going to measure in terms of pounds and time we are going to measure in seconds. MKS system and SI system almost one and the same. There will be little differences between MKS and SI. See here, length, in both the cases the length is going to be measured in meter, mass is going to be measured in kg and time is going to be measured in seconds. So this is not Kelvin, this is seconds. Time is going to be measured in seconds. Temperature is going to be measured in Kelvin. Okay. Next thing, advantages of SI system over other systems. We are having other three systems. With that, the SI system is the most prominent one and it is it is more accurate and it is universally accepted one. See now, easy to understand. What is the first thing? Easy to understand. Uses meters, kilometers and seconds, etc., which are easy for the student to grasp. So SI system is very easy to understand. Consistency, based on the multiples of 10. How we are going to get the multiples of 10, we will see in the next slides. Okay, making it simple and uniform over the world. Uniform in the sense all over the world. 1 kilogram in India is also 1 kilogram. In Pakistan or in Sri Lanka, in any other country you go, okay, in Bangladesh or any other country you go, the kg is same. Okay, so that is uniform worldwide, not only that. Okay, more accurate. Standard units ensure exact measurements, reducing error. So these are standard units. They ensure almost exact measurement, correct measurement, and there will be, the chance of error will be very less. Accuracy will be more. Universally accepted. So these SI system is universally accepted. That is why it is called SI, means System International. Generally they will be called, it is called as System International. It is universal, worldwide it is accepted. Scientists, they have performed and make it truly global. Global in the sense worldwide it is acceptable. Prefixes for small and large units. Prefixes, there will be, we will see kilo, milli. Milli is the smallest unit and kilo is the bigger unit. Okay, we will have prefixes for that. Next, fundamental units of SI system. For length, the unit is meter and it is denoted by the symbol small letter m. Mass, kilogram, denoted by kg. Time, second, denoted by small letter s. Temperature, Kelvin, denoted by K. Electric current, ampere, denoted by capital A. Luminous intensity, candle, are denoted by CD. Both are small letters. Amount of substance, mole. It is denoted by MOL, which is in small letters. You have to denote as it is. Next one, rules in writing SI system. So in order to write, how they have chosen, they have rules. Here we have some rules, we will see now. The symbols used for the units are always written in lower case. So we are going to use the symbol meter, that should be in lower case. So I mean small letters. A second S, small letter. Kg should be small letter. It should not be bigger letter, right? This is wrong. We should not use bigger M, bigger S like that. The name of the unit should start with lowercase letter even if it is named after scientist. See here, few units names, Newton, Pascal, these are all the units, right? So these ampere, so these are the units for few quantities, few physical quantities. Those unit, if you write the name completely, suppose for example the unit of force is Newton, if you write the Newton completely, you have to write in small letters. You should not use while writing the name, though it may be name of the scientist. Okay, generally in names in English we are going to say the name of the scientist should be capital letter. No, here it should not be used. It should be used only small letters when you write that unit name completely. That should be the person name. Okay, the unit name is the person name. Right. Symbol of the unit named after the scientist should start with uppercase. See here, don't get confused here, children. If you write the unit of force F, the unit of force is Newton completely, Newton. If you write completely, you can write in two forms. Either you can write completely Newton, or you can put only N. When you put only N letter, at that time you have to use capital letter, uppercase. When we write full complete name, at that time you have to write small letters. Symbols of the unit should not be allowed by full stop. After the symbols 50 meters, 100 meters, 25 kg, after that you should not keep full stop. Full stop is not allowed. These are the rules. And the next one is, full stop can be used after a unit only when it is written at the end of the sentence. See here, suppose if you write at the end of the sentence, we can write full stop. This line is 10 meters long. Okay, it is in the middle. So in the middle we should not use full stop. This line is 10 meters. Okay, there you can use full stop. See here. If after the unit the sentence has been completed, then you can use full stop. If sentence is not completed, you should not use full stop. Next one, the symbols for the units are never written in plural. Okay, meters, ms, you should not say. Kgs, kgs, you should not say. Okay, 20 kgs, you should not say. Okay, but when written in unit name, then plurals can be used. See, you ran 5 km, this is right. Otherwise you can write 5 kilometers completely, then you can write s. Okay, 5 kms is wrong one. Okay, you should not write 5 kms. While writing the unit, you should not write 5 kms symbol. Next, negative powers are used for the units in the denominator of compound. For example, 50 meter per second. See, per second square can be written as, if you write above second power minus 2, because in your mathematics laws of indices we are having one of the formula, that is a to the power of n is equal to, can be written as 1 by a power minus n, or a power minus n can be written as 1 by a power n. See, with this formula, this is one of the mathematical indices formula. With that formula we have written like that. So 50 meter per second, s second square is in denominator, that is a power n is in denominator. If you want to write it in numerator, you have to put power minus 2. Likewise you get it. This is from mathematics, right? See, children, if you want to know physics well, definitely you should have the idea of mathematics completely. Otherwise it is difficult to learn physics, right? Space should be left between the value and a unit, and also between two units of a compound. See here, you are having 3 kilometers. In between 3 and kilometer per second, there should be space. Kilometer per second is only one thing. 3 is different thing. So you should put one space. And also between two units of a compound. In, see, 3 kilometer per, if you write s power minus 1, kilometer after you have to put s power minus 1 separately. Space, you should give a small space, because kilometer is one unit, second is other unit. Okay, while writing by, there is no by. Divided by, if you write, it is divided by, it is combined. If you write s power minus 1, kilometer into s power minus 1. While writing into, you should have keep some small space there. Okay, space should be maintained between the values or numbers and the multiples or submultiples used, and no space should be given between multiple or submultiple. In between multiple and see example 250 kHz kilohertz. Okay, so there should not be space between kHz, so this is wrong. Okay, space should be maintained between the value or a number and multiple or submultiple, and no space should be given between the multiple or submultiple and a unit. In between the units there should not be space. Alright children, so these are the few rules. Now we go for what are multiples and submultiple units. Multiple units are those which are used for larger quantities. For example, distance 1,80,000 meters. 1,80,000 can be written as 180 into 10 power 3. How many zeros we left? That into 10 power. That is 10 power of that much of zeros. So 180 into 10 power 3. If you write 18 here, then you can write 10 power 4. If you write 1.8, then you can write 10.5. If you write 0.18, then you can write 10 power 6, like that. If the decimal number, if it is decreasing, then you can write 1 power extra. Okay, so 10 power 3 meters in the sense what? 1000 meters. 1000 meters is equal to 1 kilometer. So instead of that, you can write that. Submultiples 0.05. So 5 centimeters is equal to 0.05 meters. 0.05 meters. So this can be written as 2 digits, point after 2 digits. So 5 into 10 power minus 2 we can write. 5 into 10 to the power of minus 2. In mathematics you are going to get everything. It's okay. See now. Next thing is list of important few prefixes used in our SI system. Deca. Deca means 10. 10 power 1 is called deca. Kilo means 10 power 3, that is 1000. 1000 3 zeros, so 10 power 3. Mega 1 followed by 6 zeros, that is 10 power 6. Giga 1 followed by 9 zeros, that is 10 power 9. Tera 1 followed by 12 zeros, that is 10 power 12. Deci. Deci means abbreviated as small d. See here deca. Deca abbreviated as DA, small letters we are having. Kilo small k. Mega capital M. Giga capital G. Okay, so you have to use centi small c, milli small m. So then deci. Deci means 1 by 10, that is 10 to the power of minus 1. Centi 1 by 100. This is 1 by 100. So centi means 1 by 100, that is 10 power minus 2. Milli means 1 by 1000, that is 10 power minus 3. Micro means 1 divided by 1 followed by 6 zeros, 10 power minus 6. Nano means 1 divided by 1 followed by 9 zeros, that is 10 power minus 9. Pico. Pico means 10 power minus 12. 1 kilo 10 power 3, mega 10 power 6, giga 10 power 9 and tera 10 power 12. 10 power 12 means tera. 10 power minus 12 means pico. 10 power 9 means giga. Minus 9 means nano. 10 power 6 mega minus 6 will be micro. You have to by heart it now, and you have to observe. You have to use the okay. At least you try to write 2 times, 3 times, 5 times, so that repeatedly you just try to discuss with your friends, so that you can understand that you can definitely remind it. Okay, there is no need to worry of it right now. We have some solved examples. We shall try to solve it. Example number 1. Express the SI unit, that is length 0.00123456 zeros after 5, mass and time. So length 5 zeros out, so total 6, so that is called as 5 micrometers. Micro in the sense 10 power minus 6. Mass is 70,000 grams, that is 70 kg, and time is 3 into 10 power 6, so seconds. 10 power 6, not 10 power 6, it is 10 power 3. 10 power 3. So 10 power 3 means 1000. 1000 into 3 is 3000 seconds. Right. Next example. 1 Newton is equal to 1 kg per meter, 1 kg meter per second square. Convert into 1 dyne. So we are going to, in future we are going to get in detail. I am going to solve this, how the Newton is going to be. Okay, we shall tried, up to now we can know this. See here, 1 Newton is equals to, can be written as 1 kg per 1 second square into meter, see 1 kg meter per second square, 1 kg is 1000 grams, 1 meter is equal to 100 centimeters by second square 1, which is equals to 1 followed by 3 zeros plus 2 zeros. So 3 into 3 plus 2, 5, 10 power 5. So that is 1 lakh dynes, 10 power 5. So 1 Newton is equals to 10 to the power of 5 dynes. So likewise 1 Newton which is equals to 10 power 5 dynes, that is gram centimeter per second square, that is called dynes. Likewise we can convert the units. Next thing is need for a standard scale. What is the necessity of using a standard scale? In ancient times people used body parts of measurement. See like this, cubit, okay, average, this is the length. So few hands will be small and few hands will be larger, so that we cannot get an accurate reading with that. Even the average length, quick stretched palm. So even this palm also will be different for different people. Okay, cubit length. Okay, like, so this is also different for different people. Yard. So here we are not going to get the accuracy in reading, because for younger, older, I mean for above age 22, grown up children will have much length, and small kids will have smaller length, so that we cannot get accuracy in this reading. So for that what we have done, we have chosen a standard unit. In ancient times peoples used body parts to measure the length. So why they are not? So they are not accurate, because I have told already why they are not accurate. So for that sake, the scientists all over the world have accepted the basic unit called Standard International or System International units for measuring the basic physical quantities. Right, basic physical quantities are 3 things. I mean we are having 3 more, we will discuss after that. In order to measure the length, mass and time, we are basic units, that is mass, length and time. These are the basic fundamental units, generally referred to as SI system. So mass is measured in kilogram, length is measured in meter, time is measured in seconds, temperature is measured in Kelvin in case of kilogram. Right, Kelvin in case of SI system. Now key ideas, see here, any quantity which we study in physics is called physical quantity. So what is physical quantity? The any quantity which we study in our physics. Measuring of a physical quantity means comparing it with a known standard unit. We already discussed that. Each accepted standard unit is the standard of measurement and is commonly called the standard of measurement. kg, it is accepted all over the world in order to measure mass. So it is a standard unit. Right, we shall have some activity. What is that? I measured the length of our sofa set, bookshelf and bed using outstretched form. This is called outstretched form. Okay, then I asked my sister, you can do this activity at your home also, mother to do the same. So sofa set is measured by a single, the student and his sister and his mother. And sofa set he got 8 stretched, I mean 8 outstretched palms length. His sister got 7, mother got 7. So there is a difference in that, in measurement. In bookshelf also, so if he measured it got 4, if his sister measured it got 3, and her mother measures it got 4, there is a difference in measurement. And in bed also like that. Okay, so they get different observations. My measurements were sofa set, so that is the thing. My sister and mother had different number of palms for all the items, as one children measured this, and this is the observation he made, as their hands are smaller compared to his hands. For example, they measured the sofa set to be okay. Therefore, we did not get the same values. Generally, if we measure one thing, we should get all the same values for all those things. So the measurement differed depending on the size of our hands. That is why we are in need of standard unit. Next thing, characteristics of a unit of a physical quantity. For a physical quantity, what are the characteristics? It should be in of convenient size. Okay, the physical quantity should be of convenient size. Its value means magnitude. Magnitude in the sense, for example, I will tell you what is magnitude here. Suppose if you measure this in the scale, it may be 15 centimeters. 15, that number is there, that is called magnitude. The magnitude should not change with respect to place or time. Suppose if you measure the length here, where I am here, where I am, right? So if it is around 15 centimeters, suppose you just imagine that. If you measure in other place, in other country like America, if you go and measure this length should be 15 centimeters only. If you go somewhere and measure this length should be 15 centimeter only. A measurement of physical quantity is made up of two parts. Every physical quantity will have two parts. What are those? One is magnitude and the second one is unit. Okay, for example, if length of a part is 200 meters, okay, 200 is called what? Magnitude. What is 200? Magnitude. What is this meter m? It is standard unit. So for every measurement you will be having two things. Okay, right, two parts. Next thing we will discuss measurement of length. Let us try to compare A to B, C to D. At first these rods look almost equal, that is AB and CD are, if it seems to be almost equal. Okay, place both the rods aligned at the left side. Left side you should make these rods in the same line. Then we can get the difference in the other side. Okay, compare their lengths. Two rods. To know the rod, which rod is longer, we place them side by side shown below, and so we can say that after that rod CD is longer than, here rod CD is somewhat longer compared to AB. Likewise we can measure the things. Next, key ideas. What is scale? A third object used to compare the lengths of two other objects is called scale. See here how beautiful the definition is. Even we are having a definition for scale or unit. So what is an unit? Suppose 1 kg. 1 kg is the length. Here we are comparing the lengths. Okay, it may be 1 meter. 1 meter is a third object. Okay, 1 meter length is there na, 1 meter scale. It is a third object used to compare the lengths of two other objects. Those are unknown things. I have to measure this length, I have to measure one more length, okay, my stretched hand length. So in order to measure the length of the pen and measure the length of the stretched hand, we need the third one. What is that? Third measurement, third object. Okay, that third object we call it as, that is standard one, we call it as scale. Advantages of using scale. Scale can be easily taken from one place to another place. So it is a small one, we can easily handle and we can easily take from one place to another place. Okay, now we will try to define what is meter. Meter is the standard unit of length in the SI system. We already discussed this. What is the definition of meter? A meter is the length between two fine marks on a metal bar made of platinum and iridium alloy. Platinum is a metal, an element. Iridium is also a metal. It is also an element. The combination of both the things gets alloy. In the first chapter of our chemistry we have studied that. What are alloys? Okay. So alloy kept in International Bureau of Weights and Measures near Paris in France. So that is what the actual definition of meter. Interesting fact, the metal bar is kept at a constant temperature and is placed between two rolls. See here, in between two rolls it has been placed. Okay, so that metal rod. So interesting fact is the metal bar is kept at a constant temperature and is placed. The bar of the metal kept and protected carefully in France is internationally prototype of the meter. So that bar length we call it as meter. It is of 100 centimeters. From there the length of the meter has been chosen. This is the history of meter, right? Okay. Next thing is multiples and submultiples of meter. For expressing long lengths and extremely short lengths, we use multiples and submultiples. Multiples for long lengths and short lengths is for submultiples is for shorter lengths. 1 kilometer is 100,000 times of meters. So 1000 meters we call it as 1 kilometer. 1000 times the meter length. Submultiple 10 millimeters is equals to 1 centimeter, and 1 centimeter is equal to 10 millimeters. 100 centimeters is equals to 1 meter, and 1 meter is equals to 100 centimeters. So it is convenient to say the distance between two cities is 470 kilometers. Suppose there is a distance between from Bangalore to Hyderabad. Okay, what we can say? We can say the distance between Bangalore and Hyderabad is how many kilometers? In kilometers it is easy to say. Which the number will be short, that is 470. Only 3 digits we are having, 470 kilometers or 500 kilometers, whatever may be the number. But instead of, if you measure the same distance in meters, that will be around 470,000 meters. So it is difficult to remember and even difficult to say and difficult to be in usage. Okay, that is why for longer distances we have used longer lengths, longer units, and for shorter distances they have used minimized the units in order to spell easily and to identify easily. Okay, that is the reason. It is convenient to say the thickness of the coin is 2 millimeters instead of 0.002 meters. It is difficult to remember actually, 0.002 meters. 2 millimeters, it's quite easy. Okay, so that's why we have chosen even longer length for shorter lengths also. So this is the thing. Next we go for what is light year. Don't think light year is the unit of light. It is not the unit of light. It is the unit of distance. Okay, see now. A light year is the unit of distance used to measure extremely large distances like distance of stars, galaxies. Kilometer is too small to measure, as that of we said regarding meters or centimeters in order to measure Bangalore to Hyderabad. These kilometers will be very long if you want to measure from Earth to sun, or sun to one galaxy to other galaxy, or sun to different star, like that. At that position we are going to use what is known as this distance, we call it as light year. Light year is the distance travelled by light in 1 year. So what is light year? The light, if it travels in 1 year without stopping, the distance covered we call it as light year. It will be, light travels at a speed of 3 into 10 to the power of 5 kilometers. Remember that, this is also most important. 3 into 10 to the power of 5 kilometers per second. So that is the speed of the light. Or if you want to change this in meters, in a few things we are going to be asked in terms of meters instead of kilometers. At that time it is 3 into 10 to the power of 8 meters. So if we measure in terms of meters, it is 3 into 10 to the power of 8 meters, that is speed of the light. And if you measure in terms of kilometers, the meters per second. Okay, so 10 power 5. A kilometer is too small unit to measure the distances between stars. In order to measure the distance from one star to other star, the kilometer is very small. Light year is used to measure the distance in space. Measuring extremely small distances. In order to measure the very small distances, what we have to measure the distance of a molecule, or distance between the molecule, atom, or tiny objects, unit of length used to be micrometer and Armstrong unit. So Armstrong is also one of the unit. Micrometer is also one of the smallest unit. What is micrometer? This is a symbol mu into m. 1 micrometer is equal to 10 power minus 6 meters. 10 power minus 6 meters, which is equal to 10 power minus 3 millimeters. Okay, in millimeters you have to write, it will be 10 power minus 3 millimeters. What is known as, in meters you want to write, it will be 10 power minus 6 micrometers. 1 Armstrong unit is equal to 10 power minus 10 meters or 10 power minus 8 nanometers, even 10 power minus 7 millimeters. Okay, 1 micrometer is, so likewise we can convert from one thing to another thing in case of our SI system. Okay, so next we go for length accurately. How to measure the length accurately using the meter scale? How we are going to measure this? To measure the length of an object accurately, follow these steps. Number 1, place the object along the meter scale. Ensure that its starting end coincides with the 0 mark of the scale. The starting end should coincide with, starting end of the scale should coincide with 0. Okay, 0 mark it should be coincide, then you have to measure the thing. Ensure that your IC is exactly in front of the scale while reading at reading point of the object. While reading, the eyes should be, if this is the scale, the eyes should be exactly, this is 0, so you have to see directly there, and you should not look like this or look like this. Okay, your eye should be exactly straight. Okay, otherwise you are going to get mistake, I mean false reading. Reading the meter scale reading at the end point of the object. Here the other end of the wooden block coincides. Okay, thus the length of the wooden block is around 7.5 centimeters. Of course, this is the general example. You don't think it as seriously. Okay, you can measure as well in this case, in your situations, right? Next one, error in measurement. See, up to now, how to measure we have discussed. Now, what are the errors? What are the possible errors? See, measuring the length, error in measuring the length can occur if we do not use meter scale correctly. If you not use the scale properly, there is a chance of getting errors in measurement. Due to thickness of the scale, okay, the scale has some thickness. If the eye is not at correct position, an error occurs in reading. So, this is personal error. Okay, so while watching, if the eye position is not correct, you are going to get error. Okay, all right. Next, for accurate reading, the meter scale with marked end be leveled or taped should be used. So, marked end, the edge should be correct. If it is worn or torn, so some mark reading has been torn off, that type of scale should not be used for measurement. At that situation, you have to take 1 or 2, from 1 or 2, not, you should not start with 0. Up to where it is not correct, you should leave that position and start with in good condition. From there, you should minus. If you start from 2, suppose 2 up to 10 you got, you have to total length you have to minus 2 centimeters. Then you can get the from 0 reading. Okay, likewise you are going to get it, going to measure. Next, what is length? So, there is a definition of length. Length is the measure of distance between 2 points. So, what is length? It is a measure of distance between any 2 points, from any 2 points. It is measured using the metric units like millimeter, centimeter, meter and kilometer. They will be called as metric units, right? Next thing, multiples and submultiples of units of length. Millimeter, 1 millimeter is equal to 1000 meters, that is equal to 10 power minus 3 meters. 1 meter is equal to 100 centimeters. Okay, 1 kilometer is equal to 1000 meters, which is 10 power 3 meters. 1 meter is 100 centimeters, it can be written as 10 power 2 centimeters. Okay, 10 power 2 centimeters. 1 centimeter is 1 by 100, that is 10 power minus 2 meters, 10 power minus 2 meters. 1 kilometer is 1000 meters, okay, 1 decameter is 10 meters, and 1, okay, so 1 hectometers means 100 meters, that is 10 power 2 meters. 1 micrometer 10 power minus 6 meters, 1 millimeter 10 to the power of minus 3 meters. Likewise, you can measure the things. Next thing, precautions while measuring the length. While measuring the length, what are the precautions to be taken? Reading should always be noted correctly by keeping the eye directly above the scale at 0 mark. We have discussed already. This error occurs when the position of the eye is not in line with the 0 mark of the ruler. Okay, ruler means scale. If the edges of the ruler are worn off, already we have discussed, it is worn off, worn out, keep one end of the object at 1 centimeter mark. If 1 centimeter is also worn away, make 2 centimeters and subtract 1 centimeter. If you keep it 1 centimeters, in total reading you have to subtract 1 centimeters. If you keep 2 centimeters at 2 centimeters, you have to subtract in total reading, you have to subtract for 2 centimeters. Next thing, measuring tape. So the smallest measurement is this, we called as smallest measurement of any scale, we call it as least count, children. This is called as least count of the measurement. In our normal scale, we can measure the least count will be 1 millimeter. So the smallest value that can be measured with any instrument is called that particular instrument of least count. Okay, remember that. So 1 millimeter is equals to 1 mm. This is used to measure the larger lengths, such as, this measuring tape. Actually, in order to measure the smallest measurement, we will take 1 mm. In measuring tape, with the help of measuring tape, we can measure the smallest unit. The least value will be 1 millimeter. And we can measure the larger lengths as well with the help of this meter scale. Land required to construct a house, fields. Okay, the smallest possible unit is 1 millimeter. This is used to measure the larger length, such as land. Okay, even in case of meter scale, we are going to measure the distance as kilometers, 1000 meters, which is equals to 1 kilometer. Next, we are having one more measurement, that is calipers and scale. Measuring the inner diameter of the pipe. So this is the pipe. In order to measure the inner diameter from here to here, we are going to use what is known as calipers. Also, even we are going to measure the outer diameter. External diameter can also be measured and inner diameter also be measured. Inner diameter is going to be measured with the help of upper jaws. There will be 2 upper jaws, 2 teeth above for the vernier calipers. Those are called as upper jaws. With the help of upper jaws, we are going to measure inner diameter, and with the help of lower jaws, we are going to measure the external diameter. They are used to measure the inner and outer diameters of a pipe, and the reading checked with the main scale. In main scale, we are going to check the reading. Okay, measuring the outer diameter of a pipe. Right. Next, thread and scale. With the help of thread and scale, we can measure the inner diameter. This is one more technique. The thread is used to measure the inner diameter of the pipe. So by using the thread, we have to place the inner inside how the pipe has gone. So like that, and completely from A to B. Suppose if you start here, you have to roll the thread like this, completely, and again come back here itself. Then take the complete length with here, and you place it over the scale, and you can measure the diameter. You can measure the length. With that, we can measure the diameter. So if you half the diameter, you are going to get the radius. Okay, so this is what we call it as diameter. So this is not the diameter, this is circumference completely. Circumference of circle is 2 pi r. Okay, so with that we can calculate the radius. Diameter is this one, this complete distance from here to here. Okay, right. Now we go for one more activity, that is to find the diameter of a cricket ball. Okay. Arrange the rectangular boxes. Diameter means this end to that end, cricket ball. So what we have to do, you have to arrange the 2 boxes so that you have to measure from one end to other end. The distance should be measured here. So from we put the scale. The scale is the starting reading in the scale here is 3.1, and the second reading is 3.1, and the first reading is 1.6 centimeters. If you take the difference of those two things, you are going to get the diameter of the ball, that is 1.5 centimeters. You can choose it. You can also do by yourself, right? See now. Next thing, thickness of the paper. In order to find the thickness, how thick a paper is, we cannot measure a single paper, right? It is difficult to measure the thickness. It will be very less in size. So for that, what we have to take? We have to take few pages, maybe 40, 50 pages together. Okay, thickness of the sheets. Thickness of the 40 sheets will be 3 millimeters. Then what we have to take? Thickness of the 43 millimeters. So we have to divide it with 41 sheet. For one sheet which will be equal to 3 by 40. If you write 3 by 40, you are going to get 0.075 millimeters. So likewise we are going to get the thickness of the paper. We can measure it. Right? Physics is very beautiful, children. Okay. So with this we can do miracles, right? See now. Next thing. Vernier calipers. So we have discussed, used to measure the very small lengths, depths. Even we can measure the depth through this. You will be having some longer line like this. I mean stretched strip. There will be the metallic strip behind it. So with that we can measure the depth of the pen or whatsoever. Pen cap depth we can measure. Even depths also measured. The smallest possible measurement is 0.01 centimeters with the help of this vernier calipers. That is also called as least count of this device. Every device will have its own least count. That is called the least value that can be measured through that instrument. So the least value and minimum value, the smallest value that can be measured with the help of vernier calipers is 0.01 centimeters. Next thing is one more one which is screw gauge. Screw gauge, these are the different parts. One is anvil, sleeve, main scale, thimble, sleeve, circular scale, like this. It is also used to measure the smaller lengths. It can be measured still smaller when compared to vernier calipers, that is around 0.01 millimeters. Okay, it is its least count. Okay, even thickness of the paper also can be measured with the help of this screw gauge. And we shall try to know the parts of this screw gauge. Anvil, the stationary measuring face that against which the object is to be measured is pressed. So this one we call it as anvil. See here in this picture. So this one we call it as anvil. Okay, this is the position. And next one is sleeve, the cylindrical part that has the main scale and holds the thimble and spring. This one cylindrical which is having the main scale we call it as sleeve. The main scale, I mean head scale we are going to call the fixed scale on sleeve on the gauge marked with increments of 1 millimeters. So this is the one circular one, that is called head scale we are also called. And thimble, the kernel rotating part. See this rotating part, this part we call it as, you turn to move the spindle closer and farther from the anvil. We can move forth and back, front and back. So that one we call it as thimble. Okay, so these are the different parts. Next we go for investigation, means activity, measuring the length of a curved surface. Okay, wrap a string around the curved surface, so string or wire of the wooden cylinder and mark the point A. Unwrap the string and stretch it on the scale and mark the point P. Starting point should be A and unwrap. Unwrap means stretching. Stretching, you have to measure the scale from A to B. Likewise, so B minus A will give you 10 minus 1 centimeter will give you 9 centimeters. Likewise, we can measure the measuring the length of a curved surface. Okay. Next one, measuring the thickness of the coin. Already we have discussed this. So we have to take in terms of pages we have discussed. In the same fashion, you put the coins, 20 coins. Okay. Once again, total thickness will be 1 centimeter of the coins. Measure the total thickness. Total thickness by number of coins. Okay, we'll give 1 centimeter by 20. We give 0.05 centimeters. Same as that of that we have measured bundle of papers. So this is of same measurement. Likewise, we can measure. Next thing is, so with this we have completed the lesson, children, and now we shall try to solve few questions. If possible, you try to pause it and you try yourself. Okay, so that you can understand the things. Okay, we shall try to solve this. Dash is measure of the distance between 2 points. The measure of distance between any two points is called dash. This distance we call it as dash, length. Okay. 1 kilometer is dash times the length of 1 meter. How many meters is equal to 1 kilometer? 1000. 1 millimeter is dash part of centimeter, 1/10 part. The SI unit of length is meter. Right, true or false? 1 millimeter is equal to 1 million meters. Is it? No, false. The distance of the stars from the earth is measured in megameters. No, it is measured in, okay, megameters, but actually it is measured in stars and are measured in actually light year, in terms of light year. So this is false. Okay, 1 light year is equal to the distance of 9.46 into 10 power 12 kilometers. So this is the value, children. It is true. Try to remember this. So what is 1 light year value? Okay, we have not mentioned in our topic. Here we got it now. So that value is 9.46 into 10 power 12 kilometers. A standard unit is a basic unit acceptable to scientists and general public. Yes, it is true. The magnitude of the standard unit should not change with respect to time and place. Yes, true. And now we go for the match the following. 1 millionth of the distance of North Pole to equator along the latitude passes through Paris. We already discussed. That is what we call it as meter. So that is E. A unit which is acceptable to majority of the people is called dash, standard unit. A unit, yes, this is the standard unit, second one. A unit used for measuring very small distances of the diameter, very small distance, that is micrometer, A. The distance between 2 points is called length, we already discussed it, that is C. A unit used for measuring the distances between two cities, that is kilometer, B. So likewise we can solve different kinds of problems if you know the concept well. Try to read the concept, listen the concepts once, twice, thrice. Try to understand. Then you come here, you can do by yourself. Okay, you will get a challenge in order to do things. While in doing the bits, in solving the problems only, you are going to get the concept, children. Okay, generally reading the topic and leaving these questions, so you are not going to get the concept. In order to get the physics concept, you definitely solve different kinds of problems. That is why I am solving, right? Okay, next we go for multiple choice questions. The appropriate unit for measuring the thickness of a coin, what is that? Centimeter, micrometer, millimeter, kilometer, millimeter. So the coin thickness will be in terms of millimeters. The appropriate unit for measuring the distance of stars, it is the light year. 1 light year is equals to, it has been repeated, 9.46 into 10 power 12 kilometers. A standard unit should be the inconvenient size, not change with change in place, not change with time, all of this. This is all of this. Next, correct the statement, correction of statement. The statement given below, see, 1 kilometer is equal to 100 meters. Is it? No, it is 1000 meters. It has been corrected here. The distance of the planets and the stars from the earth measured in millimeters. No, planets and the star will be, earth will be measured in light years, not kilometers, not even, it will be light years. Light years. The standard unit of length is millimeter. No, it is false. Standard unit is meter. The tools used to measure the diameter of the cylinder is meter scale. No, it is vernier calipers. A centimeter is 100 times the length of 1 meter. No, centimeter is not 100 times of 1 meter. Meter is 100 times of centimeters. It should be reversed. Okay. So likewise you can solve different kinds of problems, children. Next thing is we have some study questions. We shall try to solve this. What is length? Length is the distance between 2 points. Already we have discussed. There are 4 early units also here we have mentioned. If you want, you can check it. What are the standard international units of measurement? That is SI system. The unit of length is, in this system, is meters. Okay. Name the 2 characteristics of the standard unit of the physical quantity. It is invariable, it should not be varied, and universally acceptable. By using a thin cotton thread, how will you measure the length of a curved line? Use the thin cotton thread to trace the curved line and mark and stretch the thread along a ruler from one corner to the other corner up to have marked. So with that distance will give you the curved line distance. Why do we need standard units of measurement? Because for consistency, accuracy and acceptable over the world, Okay, so the unit of length in SI system is meter. SI, the symbol is M. Define the term meter. A meter in the SI unit is 1 meter is equal to 100 centimeters, 1 meter is equals to 1000 millimeters, and 1 millimeter is equals to 0.001 kilometers. Name the two units for measuring the diameter of an atom of the nucleus or nucleus of atom or diameter of an atom. Armstrong units and femtometers. So these are those. 24 coins upraised on one another, one upon other. I mean, keep it one on another, and their total thickness is regarded by meter scale. Okay, so the question is not appropriate here. It's okay, leave it. You can check it otherwise. 1 light year, which is equals to 94,600 crore square meter. 1 micrometer is equal to 0.001. This has been repeated several times. Okay, you can leave it. See now, the next thing is transportation. There is a past story for this. Long ago, people did not have any means of transport. They used to move on foot and carry goods on their back. Okay, later on, they began to use animals for transportation. At first, they used to walk. After that, animals came. They used to move on foot and carry goods on their back. Later on, they began to use animals for transportation. For transportation through water routes, boats were water routes. Boats were used from ancient times. To begin with, the boats were simple logs of wood with a hollow gravity. Okay, with the time, people also invented the means of transportation for travel for far distances like train, bus. So likewise, cycle, bicycle, etc. has been came after a long time. How far and how wide? See children, it is important to know how far a place is, because if the distance is very small, we can go by walk. If it is somewhat far away, we can go through cycle. If it is around 1 kilometer, we can go by walk. If it is around 3 kilometers, we can go by cycle. If it is around 10 kilometers, we can go by bike. Okay, if it is around 100 kilometers, we can go by car. So by knowing how much distance it is, we can use the appropriate vehicle what we need. Okay, for that sake, we need that. Okay, so that is the thing. Next one is ancient use of measurement, that is angle with the finger. Okay, mutti, the fist, cubit, the stretched one from elbow to the middle finger, and modern units we have, I think we already discussed that. So with this we have completed the lesson children, right? I think it will be more interesting to you, I think, but we go for moral of the day today at the end. Okay, in Telugu I will say that, and there is a conversion here in Hindi and English. If you are comfortable in English, you can read this. If you are comfortable in Hindi, you can read that, right? See in Telugu what? 5 సూత్రాలు ఉంటాయి. దేనికి? ధర్మానికి. ధర్మానికి 5 సూత్రాలు ఉంటాయి. రైట్? ధర్మం అంటే దాన్ని పంచరత్నాలు అంటారు. ఒక్కొక్క సూత్రం వచ్చి అనురాగం, ధైర్యం, ప్రేమ, సమర్పణ, న్యాయం. అనురాగం ఏం చేస్తుంది? బుద్ధిని స్థిరం చేస్తుంది. అంటే స్థిరమైన బుద్ధి, నాట్ ఫికల్ మైండ్, అలా కంప్లీట్గా చేంజ్ అవుతూ ఉండడం అనేది ఉండదు. అనురాగం, ప్రేమ, ఆప్యాయత. యూ షుడ్ హ్యావ్ లవ్ టువర్డ్స్ ఈచ్ అదర్. ఓకే, లవ్ టువర్డ్స్ అనిమల్స్, లవ్ టువర్డ్స్ ప్లాంట్స్, లవ్ టువర్డ్స్ హ్యూమన్ బీయింగ్స్, లవ్ టువర్డ్స్ నేచర్, లవ్ టువర్డ్స్ ఎవ్రీబడి. ఇట్ విల్ గివ్ యూ, అప్పుడు అలాంటి లవ్ అనేది మీలో ఉంటే బుద్ధి అనేది మెరుగవుతుందన్నమాట. అదే ధైర్యం, మంచి ధైర్యం ఉంటే మనసును స్థిరం చేస్తుంది. మనసు బాగుండాలి అంటే ధైర్యంగా ఉండాలి. బుద్ధి బాగుండాలి అంటే అనురాగం ఉండాలి, అంటే ప్రేమ ఉండాలి. యూ షుడ్ హ్యావ్ లవ్ ఇన్ యువర్ సెల్ఫ్. ప్రేమ హృదయాన్ని స్థిరం చేస్తుంది, హృదయాన్ని ప్రేమ స్థిరం చేస్తుంది. సమర్పణ మీన్స్ సాక్రిఫైస్, శరీరాన్ని ఆవేదన నుంచి శాంతింప చేసి శరీరాన్ని స్థిరం చేస్తుంది. న్యాయం ఆత్మను స్థిరం చేస్తుంది. జస్టిస్ స్టెబిలైజెస్ ద సోల్. డెడికేషన్ సూత్స్ ద బాడీ. compassion stabilizes the heart. Compassion means love. Courage, it is one more form of love. Courage stabilizes the heart and love stabilizes the mind. Okay, children, don't forget to subscribe our channel. Thank you. Hit the bell icon. If you are really interested, if you are really love this class, please try to subscribe and share for as much as possible. Don't forget to hit the bell icon, and bye. We shall meet in the next class.